Welcome to this tutorial on using when expressions with sealed classes in Kotlin. We'll explore exhaustive matching, a powerful feature that ensures your code handles all possible cases at compile time, making your applications more robust and maintainable. Let's start with a basic sealed class hierarchy. Here we have a sealed class called result with 3 subclasses. Success is a data class that holds a string data property. Error is a data class containing an error message, and loading is an object representing a loading state. This hierarchy represents common states in asynchronous operations like network requests. There are 4 key benefits to using when expressions with sealed classes. First, exhaustive checking ensures the compiler verifies all cases are handled. Second, you get type safety, eliminating runtime casting errors. Third, no else clause is required because the when expression is complete by default. Finally, your code becomes more maintainable because adding new subclasses automatically triggers compile errors in places where they need to be handled. Here's how to write an exhaustive when expression with sealed classes. The function handleResult takes a result parameter and returns a string. The when expression checks each subclass using the is operator. For success, we access the data property and return it with a label. For error, we access the message property. For loading, we return a loading message. Notice there's no else branch needed because all possible cases are covered. The compiler actively enforces exhaustiveness. If you miss a case, you'll get a compile time error stating that the when expression must be exhaustive and you need to add the necessary branches. However, when all sealed class subclasses are handled, the code compiles successfully and no else branch is required. This compile time safety prevents bugs from reaching production. When expressions with sealed classes support smart casting. In this example, the function process result returns an integer based on the result type. For success, we can directly access the data property and call length on it without explicit casting. The compiler knows that result is of type success in that branch. For error, we return -1. For loading, we return 0. Smart casting eliminates the need for manual type casting, making code cleaner and safer. One of the most powerful aspects of this pattern is maintainability. When you add a new subclass to the sealed class hierarchy, like this empty object, all existing when expressions that match on result will immediately produce compile time errors. This forces developers to handle the new case everywhere it matters, preventing bugs from forgotten edge cases. The compiler becomes your safety net during refactoring. The key takeaway is that when expressions with sealed classes provide compile time safety and exhaustive matching. This combination ensures your code handles all possible cases, reduces runtime errors, and makes refactoring safer. By leveraging Kotlin's type system and compiler checks, you create more robust and maintainable applications. Master this pattern to write safer, more reliable Kotlin code.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.